Let's look at final exam question number 56, found on page 673 of Teach Yourself Electricity and Electronics, 5th edition. We're told that a certain component has a complex admittance, that's what Y means, of 0.057 plus J times 0.0033. Then it goes on to ask us, what type of susceptance do we have here? What type of susceptance does this impedance represent? Pardon me, not impedance, admittance. These distinctions can get confusing, and I get confused sometimes by them myself, so don't feel bad. This real number portion right here represents G, conductance, and this complex number portion here represents B, susceptance. Those are uppercase italic letters if you want to get technical about it, and that uppercase Y would also be italic if you want to be technical, and so would the lowercase j. But of course the numerals would not be in italics. I don't think I've ever seen numerals in italics. This particular complex number, because the susceptance is positive, that is a capacitive susceptance. So the correct choice in this particular situation is D, as in delta. It is a capacitive susceptance. Now, if we go and look at this, if we draw a complex impedance, pardon me again, complex admittance rendition of this, we have a half plane, G representing conductance, plus JB representing capacitive susceptances, and minus JB would represent inductive susceptances, so our vector will point somehow, some way up like that, upwards and to the right. If we use a Cartesian system where all of the increments are the same size, the J is a lot, the J 0.0033 is a lot smaller than the G real number portion 0.057. So this arrow would point almost along the G-axis. It would be even flatter than what I've drawn here, but that's what we would get if we were to draw this in the complex admittance half plane. Now, at the same component, if we were to draw it in the complex impedance half plane, because we have capacitance involved, capacitive reactances are always going to show up as negative. Minus Jx is capacitive reactance, plus Jx is inductive reactance, and of course instead of G here we would have R, resistance. What we're going to get then is a vector that points downwards and to the right, somewhere in that quadrant. Capacitive reactance is the same thing, is the reciprocal of capacitive susceptance, but remember, when we take reciprocals involving the J operator, we reverse the sign. That doesn't happen with resistance and conductance, because both of those quantities are always non-negative, that is to say 0 or positive. So that's just a little bit of an aside, but this particular complex number that we see in question number 56 shows a capacitive susceptance, and once again, that is choice D, as in delta.